So thank you for taking the time to listen to what we have to bring today. I had the opportunity to talk to Mark in the past, and he was enthusiastic to hear that Intellimeter has specialized in the submetering of electricity, water, gas, and heat in buildings, what we call thermal energy in buildings. And we've been in business last month 32 years with multiple customers across North America. Uh, the important thing that you should know about Intellimeter is that we're very different from other submetering companies in the sense that we use open source for the communication of our meters. We use an open source for the uh, databases that are in our computers, and that allows anybody to integrate it to any other metering systems. All our meters are Measurement Canada approved for revenue. So whether it's a gas meter, an electrical meter, or a heat meter that measures thermal energy, they're all approved for measurement for billing by Measurement Canada. We also have approvals in California. Additionally, they are all CSA approved or UL for Canada approved. So you don't have to worry about the uh, say billing a customer for energy using one of our meters and then having the customer come back and say, well, that's not an approved meter because we are uh, very finicky on what we bring to the market. So we're going to talk about the meters, but we're going to talk about right now about the need for energy management in buildings. We're going to talk about our EVCMC, and I will tell you why it is the most effective solution for charging in multi-residential buildings. The electrical vehicles are coming, and probably in Alberta you won't see it as much as you may be able to see it, for instance, in British Columbia. And British Columbia is very much advanced. If you were in the east coast of Canada, Quebec is way ahead in the curve. But in this slide, I want to show you the fact that the trends are changing. So the internal combustion engine cars sales in North America are beginning to decline, and the electric vehicle sales are beginning to take off. So eventually, probably in about 10 years, they're going to cross what the break even point, and that will increase the number of electrical vehicles on the streets and on the roads, and that's fine. Now, most people that own an electric vehicle like to charge at home, but that brings a problem to the infrastructure, and in particular to residential buildings, because one third of the population, both in Canada and in the United States, that statistic is similar. One third of the people in North America live in an apartment building, whether it's a rental or a condo. They share the space for parking. And the problem for those buildings is infrastructure. Finding 30 amps or 7 kilowatts of load in a single home is not that hard. But when you have 200 vehicles that you want to charge, uh, finding 1.5 NVAs of capacity to charge all those vehicles is not that simple. So that was recognized in a study performed by the National Research Council in 2019 as one of the obstacles for the adoption of EV in the market, and the inability of buildings to just go in and buy flow chargers for DAD sales and say let's put them in because they don't have the capacity. But that's why energy management systems, what is called the EVEMS, an electrical vehicle energy management system, came to market. And the other part is that in most buildings, the parking spaces are part of the common elements. So letting someone take energy from the common elements is basically having the rest of the population in the condo subsidizing the fuel for that person. So metering is important. And those are the things that we look at with our EVCMC. We solve the issue with capacity by managing whatever capacity is available and making it available for others, and metering the energy that is taken from the common elements to give the owners the ability to bill for that energy and recover the cost. Now, when we developed the EVCMC, CSA had already a draft for the standard, and it classified the standard, and it's highly technical. I will make it available for you. You will have copies of the slides, a recording of the presentation. and you can read it at your own pace. But basically, we went to this document to find the best way to do it. One thing to understand is the uh, difference between load switching and load sharing. And DAD sales smart chargers like the ones from Flow that do load sharing. And but we do in our system, we operate upstream from the charger, uh, and we do load switching. That load switching means that we turn on one charger. When that charger is done, then we bring the other charger online. Load switching is when they communicate between each other and they share the output, reducing the output to make sure that the combined aggregate of that load doesn't exceed the capacity of what it's feeding. In the end, the result is basically the same. Picture that you're going to bring you got two buckets of water in the backyard, and you're going to fill them up with one hose. If there's only one hose, whether you fill them up simultaneously or you fill one up first and then the other one, the result is going to be the same. Uh, in terms of the capacity, we have to think about the our own homes. The capacity is available, and a lot of the buildings have built up capacity for pumps, for chillers, for garbage compactors, for lighting, for receptacles, for many services in the building. But those services are not used at all times. Same for the residential part. In the residential part, the services to the buildings are like services to the homes have to be rated to allow for the occupant of the house to turn on the dishwasher, the washing machine, the dryer, have the lights on, watch TV, work on the computer, use the receptacles and the capacity in that house, as is shown in the peak here under the word charging. You see a peak there. But at the same time, at night, when we all go to bed and the car is parked outside, nobody's using that energy. Nobody's doing the dishes, nobody's washing. So we can make that energy available to EV charging. Literally, as you see in the graph, taking uh, that capacity and putting it towards the car. And the way to do it is very simple. Remember, we come from the submetering part. So we just put a meter into the main and then analyze the performance of that load. If the building is taking that load, so for instance, if at home it's 5 o'clock, somebody's cooking or doing the dishes, and the kids came back from soccer practice and the uniforms are soiled, so they're put in the washing machine, they're being washed, and we're watching TV or finishing work on a computer using lighting, then nothing is going to happen. We know that those loads take preference, but when we go to bed and the lights are off, nobody's using the capacity at home. We just make it available for the car, and it is that simple. That principle applies to buildings as well, because in buildings it's exactly the same thing. Some of the arrangements of car charging are not necessarily very smart. That means they're not monitored. Some of them are, but are very expensive. But the majority of them just look at cars in a binary way. Either there's one car or two cars or three cars, and they divide the load equally. They don't take into consideration that the batteries are of different size. And the charging rates for every car is very different because every car has a different battery composition, a different battery management system, and a different capacity for charging. Every car has an internal charger that limits a charge that vehicle can take from the charger. But by doing it just in a binary way, it's a very unfair way of doing it because some cars won't charge very fast and some cars will take all the capacity. And those systems are inefficient because they also don't look at what happens when batteries are filling up. As the tank is filling up, the rate at which they're drawing energy from the circuit, it starts to decrease because the battery management system in the vehicles prevent the battery from overheating by reducing the amount of current they can take. That leaves all these blue bubbles of energy available that our system, because it's monitoring the consumption individually, can take advantage and then group from a large fleet all those bubbles to make that energy available for their cars. So, other obstacles that you find is communications. Literally, when these systems are deployed, a lot of times they communicate between each other wirelessly, and that might create a problem because that requires the addition of signal repeaters or another private local area network, and that adds cost. So the cost of the equipment is not necessarily what it's in the initial quotation, but it's what happens after it's commissioned and after it works. So that's why we do load switching. The uh, the management system that we do is called a monitor type of switching. That means that we measure everything. And that makes it very efficient because at any one time, every second, we know not just the amount of cars that are connected, but the EVCMC understands how much is the total aggregate of the consumption and makes a smart decision to decide whether to curtail that capacity or to bring another car to charge. And that makes it the most flexible and the most efficient way of energy management for electric vehicle charging. And you don't have to believe me because I say it's in that document for which you will have the link. At the core of our system is, of course, our meter because that's our background. So we have the ability to meter each circuit individually, to meter the mains of the building, and to play with those two capacities to maximize whatever availability is into the building. Our 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 offer provides a complete package for what the contractor is going to need, right? So number one, we comply with the electrical code because we provide means for disconnection, means for circuit protection, an individual meter that is Measurement Canada approved for revenue in Canada, and then we provide in the bottom part, you see two big enclosures. Those enclosures have contactors that turn on and turn off the chargers depending on whatever capacity is available. And of course, it comes with the software. The benefits we bring is that the use of this software is included in the price of the equipment. So whoever the user is will have a lifetime license for the use of this software. In that software, the user can log in and look at the status of the chargers, download reports, whether it's historic reports on the consumption, on when it turned on and when it turned off, and on the amount of energy that was consumed, so that they can use these reports for billing. Then they can have the ability to program the chargers. So, for instance, we can program the charger off for any time, whether someone is going to go on vacations for the winter, they're retired and they want to go there to Phoenix in the or to Cuba or to the Dominican Republic for 3 months, they can turn their charger off to prevent somebody else using their charger and charge their car while they're not there. Or if somebody's going to the office Monday to Friday, they can do a repeated schedule that can be turned off at any one time. And if you are the property manager, you'll have the right in the software to turn on specific chargers, for instance, for an amenity. So if you have a guest that requires charging and and is not a resident, they can come into the office and ask for that charger to be turned on at certain times. Now, buildings are unique. Every building is different. And that's why working with Telemeter, we give you the ability to make the EVCMC horizontally, vertically, it doesn't have to be tall, together or separate. But we have the ability to provide you many unique features. So in this picture, we did a building in Ottawa where they wanted to deploy 60 chargers, and there was no space in the height was limited, the width of the wall was limited. So what we did is we used the Power Command Panel. Our software can work with multiple suppliers, not necessarily Siemens. So we can deal with people, for instance, at high-end condos, if they want a fast charger because they have a Tesla and they want to use the Tesla chargers, we can make the EVCMC with 60 amp breakers instead of the regular 40 amp breakers. And we can do enclosures for outdoor, uh, protected for the cold weather, if you're in Fort McMurray, you need a set of chargers there. We could make an enclosure that includes a heater with a thermostat, and we can make it NEMA 4X, so ideal for withstanding the weather conditions in northern Alberta. So one thing that is important for you to know is that the Intellimeter is the only company, and you're going to ask the sales if this is true or not, but we're the only company that can offer you a witness factory acceptance test, which is a test where we put your equipment, the equipment that you purchase, we can put it on a load bank and simulate the loads of all those chargers, and we can give you a remote access with a video camera so that you can see what the system is doing, and a terminal so that you can see online how the EVCMC is curtailing and managing these loads based on the conditions that it's going to face in the field. And that's something that is really unique to Intellimeter. Our system is very easy to install. Electricians love it because it's already it. They just have to feed the main logs in the distribution panel through the current transformers that are provided for that. They connect the meter to the local area network just for reporting. It's not necessary because the access is totally local. And then they just connect the EV chargers from the secondary side of the contactors. In Ontario, most condos separate what pertains to the condo corporation and what pertains to the user. In most cases, the condo corporation has to provide just a point of connection. So by supplying this panel, they comply with the requirements of the law. And then each individual owner will be responsible for connecting their charger to the secondary side of those contactors. And we have the ability to connect just the panel to begin with and add the the control at a later date, or just start. If you already have the panel, we can always add the control. You can buy both, and you can buy multiples of them. At the core is our I-45, which is a Measurement Canada approved meter. In that panel, there's a computer, just like the laptop that you're using today for watching the presentation. We have a computer, except that it doesn't have a screen, doesn't have a keyboard, but it's a little block that you can access with a laptop externally or by putting it in the local area network. And that gives us a tremendous advantage because anytime that panel is energized, the system is going to work. So you don't have to rely on cellular connectivity or in Wi-Fi connectivity, or you don't need an IT person to come in and troubleshoot because it will work. And that computer can be tied into other billing system. And if you already have uh, some metering company that is taking the reads for billing, we work with 105 Connections out of Edmonton. We work with Karma as well in Edmonton, with Wise, with Enercare, with Metergy, with Energy, with Indie Energy, with Gone Service, multiple companies across North America where they use our meters for reporting on the consumption so they can provide the bill. We have multiple sizes, so just talk to Dave and say, I got a parking lot with so many spaces, and this is what I have. We can always look at the capacity and make the best recommendation for you. It uses off-the-shelf components, and this is very important. Number one, because you don't have to rely on Intellimeter to buy a spare part. God forbid, I mean, the system comes with a warranty, so you don't have to worry about that part. But down the road, if something were to fail, you can always go to your electrical distributor and find the part, and you can replace it. And you can not just replace it with the original part, you can use other components that are similar. Everything in that panel, everything is available through electrical distribution. Of course, we would have the spare parts in stock. If you want to buy from us, that's fine. But you're not tied to Intellimeter for anything. We'll set it to work. It will work by itself. It will be guaranteed. If you want to add, yes, of course, we're happy to help. But you can go to any electrical find find the components to uh, find the components to fix the VCC in case it needs fixing. The parts are rated for 10 million operations, which is a tremendous advantage because it will literally outlive the, ourselves. I will certainly definitely with 10 million operations. If it's going to operate 4 times a night, it's gonna last for something like 65 years. So it's going to be beyond my time. Uh, we build into the system multiple fail-safe mechanisms. So you can be safe that it's not going to trip the main breaker. It's not going to trip the breaker that feeds the chargers. And we'll have means to determine if somebody tampered with the meter other than just a seal. It's allowed by the code, both in the United States and in Canada. The code allows to size the feeder and the panel and the breakers based not on the total aggregated load that is going to be installed, but on the capacity that is limited by the EVCMC. And of course, it's approved by Measurement Canada, so you don't have to worry about that part. It's brand agnostic. So I know the AD sells the flow chargers, and it works with the flow charger. But if you're limited in budget, you can also just put a receptacle, and it will work with all the portable chargers that are in the vehicles because we tested it. And the code only requires you to label it, rated for 250 volts, less than 32 amps. As the cars come to charge into the building, we have the ability of tracking when they charge, when they connect, when they start, and then as the load increases, the EVCMC rotates that load. Picture this electric meter in the mains, and this is going to get a little bit technical, and I'll just go through it very fast. But we have the ability to look at what the building is consuming, so that when that capacity that is not being consumed by the building, whether it's the chillers, the elevators, the lighting, the receptacles, the ventilation, when that is not working, we can bring it and make it available for car charging. And when the building uses it, that's fine. Then we reduce the load of the electrical charging. We have a single line diagram here, and we put the building and the apartment feeders and other services on the right hand side of the single line, and the EVCMC is on the left side. So that's always a possibility, and it makes for a very easy adaptation into the building. Every building has like a home switch gear at the entrance. The easiest way to install is looking at what's available in that switchboard to add an EVCMC, or to add two of them, or to add the meter in case the capacity is going to be exceeded. The You can add one or two or three, and you can add more panels with time. You may do it independently, and over time, you can always add communication between those panels to make them work all together as if it were one. There's no limit. This is the biggest project we did in British Columbia. That's 16 panels, close to 300 chargers in a single development, and they all talk to each other, and they work perfectly fine. So what the EVCMC does, it just looks at the limit. That red line is your capacity, and that's the capacity is available for charging. But because the EVCMC gives you the ability to put more chargers than the capacity, if you didn't have anything to manage that capacity, the blue line, which is the consumption, the theoretical consumption, would exceed that limit. Here at point A, it would go beyond that limit, and that would either overheat the transformer, overheat the feeder, or trip the breaker, or blow a fuse. So what the system is going to do is going to look at that limit and track the consumption to make sure that that never happens. So we're going to set the limit right now, and we're going to set another limit in case something else goes in. Remember, we have the ability to look at what's going on in the building. So if the ventilation system for the underground parking garage turns on at one time, we would have to reduce that limit. What we do is the cars come and connect. The EVCMC tracks the moment the car starts charging, and then tracks the consumption of every one of them. And as they increase, they may reach the limit. At that point, the EVCMC looks at the vehicle that has the longest time charging in that network, and that vehicle is taken off the line. And it's taken off the line, but then it's put in a waiting line. It's going to sit there and wait until the reduction is over. The use of that capacity by the building passes. So the ventilation turn on, and you saw that we now have taken the blue vehicle, which is the one that has been there charging the longest after the red, and we took the blue offline. But that blue is going to go into a waiting room, just like the red. It's going to go and wait until the capacity is available for coming back. When that capacity is available, we look at the waiting room, and we're going to see that the red has been there waiting the longest. So that's going to be the first car that is taken off the waiting room and is being brought back into charging. And then if there's more capacity, then we bring the blue. Now, because the EVCMC allows you to install more chargers, there's a rotational mechanism. So that means that once the cars have accumulated their allotted time for charging, then they rotate. So we bring the ones that have not charged yet. So you're going to see that once the pink vehicle accumulated 6 blocks of time, in the seventh block of time is now a beige car. But importantly is that you don't see the pink car in the queue. The pink car is not waiting anymore because it already accumulated its portion for that night. In a similar fashion, the red vehicle, although the charge was interrupted, the EVCMC tracks the time over that night that the red car has been connected. The red car had already also accumulated 6 blocks of time. So on the seventh is now a red. It's not a black car. It's not red anymore. So, and it's not in the queue because it already accumulated its allotted portion of energy. So now we have another vehicle. And the rotation continues. So now you see that the blue is green and that the orange is black. And that rotation continues so that every vehicle, every charger that is in that network gets an amount of energy sufficient for the next day. The EVCMC literally tracks the consumption of the charging mechanism and always keeps it under the limit of that capacity. With the benefit that when you add the meter to the mains of the building, that maximum capacity can be adjusted. So you can have a capacity for the daytime when the loads in the building are being utilized, and a higher limit at night when those loads are not being used. And it is very beneficial because number one, it reduces the size of the feeder. So this is an exercise. So imagine if you were going to install 24 chargers in a building, you would need 170 kilowatts in capacity. The next size up transformer is the 225 kVA that you can buy from DAD sales. And they can tell you that the commercial sizes as 150 and 225 kVA. So when you go to the 25 kVA, you got to bring in a feeder that is rated 800 amps because the current for that transformer is 624 amps. When you use the EVCMC 24, you'll have the ability to connect the 24 chargers. But instead of putting an 800 amp breaker, you can put a 200 amp breaker. Even with the reduction required by the code of the 80% capacity, you can charge the cars over 12 hours 31% of the time. So that's equal to almost 4 hours of charge. Now, you're going to ask yourself, oh, but maybe during that time, will they accumulate enough energy? And the answer is yes. So if you had the most inefficient vehicle, which is the F-150, you've accumulated 56 miles. So something like 86 kilometers. And if you had a Tesla, you'd have close to 150 kilometers, so a little bit more than 150 kilometers. But the thing is that in North America, both in the US and in Canada, the maximum commuting distance is 50 kilometers on average. And if you look at the median distance between home and work, I mean, in most urbanized cities in Canada, it's about 15 to 20 kilometers. That's the median. So you accumulate the capacity. Now, you may not use all that capacity, but when the car comes back, there's battery left in the car. So it continues to accumulate. And over time, all the cars are just going to be topping up for the next day commute. So it's more than what you need. Uh, we're going to skip this. It gets a little bit technical, but I will just leave you with this. We don't charge recurring fees. We don't charge for cloud access for the use of the EVCMC. I was with a customer in Ontario here yesterday, and here's a quote from ChargePoint. ChargePoint charges $25 a month for access for every charger. When we did the math, in less than 5 years, the EVCMC would pay for itself out of those recurring fees. So I hope that you could capture that the EVCMC is really the best means to reduce the utility upgrades that you would otherwise have to incur if you wanted to deploy chargers. And it's very simple to operate. It's user friendly. It's made with off the shelf components. It allows you to use any type and any brand of EV charger, provided it's a level 2, less than 32 amps, 250 volts. And there are many. I mean, and it's easy to operate. So I need a break here to take a sip of water, and I want you to post any questions while I take my sip of water.
But
Okay. Oh, I gotta ask a question in here. Okay, sure.
Yeah.
Is there any liabilities that we have to worry about with regards to insurance since we're using software for the transfer of cash and things like that, and also for the actual use of the equipment? Do we have is there any tax or any permits that we need other than like just the electrical code? And is there a timeline that we? There's four questions there. I apologize.
All right. Let me see if I understand the first part. On the first part, the software does not include a payment mechanism. So the payment has to be done separately. We provide the amount of energy that was used in charging. It depends on the property manager how they want to use that information. Whether they provide it to a sub-metering company that will do the billing for them, and we can take care of that if you want. That's a separate issue, and for that there is a cost. They can do an energy recovery, a cost recovery, just by looking at the rate of what they paid in that month, and then say, well, we consume 1,000 kilowatts, and we paid $1,000 in energy, so that's $1 a kilowatt. And Joe used 50, so he has to pay $50. And David used 100, so he has to pay $100. And you can do the breakdown to recover that cost. In most condos and in rental apartments, the parking spots are assigned or deeded. That means people that own the condo unit also own the parking space. So the assignment is very simple. So whoever uses the charger on parking spot number 7 will have a meter number 7 in the EVCMC, and they will know that that's their charger and that's their meter. And the system allows for programming it in such a way that we know that parking 7 is Joe's charger or Peter's charger. So that's something that is doable. Now, in terms of liability on electrical performance, the EVCMC uses all listed components, and it goes with a blue sticker from the inspector. So your local inspector will take it as if it were a field approved device for connection to the network. I can tell you the system is fully tested in the factory. It's high potted, and it will pass your local inspection, 100% guaranteed. There were 4 questions, but I remember 2. So I hope I answered the 2 of them. Tell me what the other 2 were.
You already answered them actually, inadvertently, but I thank you for that. Anybody else? Okay, Mark. I'm just passing you over to Mark.
Okay. That's going to be.
Alberto,
Yes.
just mute yourself when you're asking a question. There's feedback.
Anyway, hopefully you can. Okay, he's muted. So, no, he's not muted.
No, it's not muted. I can hear you.
No. Alberto, just mute yourself while he's asking the question.
There you go. Okay, so hi Alberto. Quick question. We have some people here that are this application you're describing here would be for multi-residential, but I see probably a potential here for some light commercial as well. I'm seeing a few nodding heads here. It would be something where assigned parking spots would be the key, I guess. And then so have you delved into that aspect of things? Now you're muted.
Okay. Yes. So let me go back to it. The key of our energy management system is this time. And I can tell you, we've done a number of commercial applications. The key is the parking has to be assigned if you want to do the billing only. But say, for instance, you got an office, and you want to provide charging to your employees. And you have 20 parking spots. And you want to provide parking to your employees, and they can connect at any one time, but you don't want to pay the man charges for for whatever capacity you have. So you put the meter in the mains for the office, and then you put the EVCMC 20 for your 20 spots. The cars have to be there for more than 8 hours for them to charge effectively. Because if you're going to go there only for half an hour, maybe it's not going to be effective, because maybe at that time there's a high demand in the building and the chargers are curtailed. So you won't have that capacity. So you have to be parked there for more than 8 hours so that we can guarantee you at least 2 hours of charge over those 8 hours. And then in those cases, it will work. The other type of commercial applications that we've done is on fleets, for instance. So I can tell you that we did, I don't know if you know VinFast, but you can look it up. VinFast is an up and coming EV car manufacturer from Vietnam. And they are expanding massively in the United States. I mean, they already have dealerships in California. In Ontario, they opened 3 dealerships. And in those 3 dealerships, we use the EVCMC. We supply the EVCMC. And that gave them the benefit not only to avoid the utility service upgrades, but the ability to charge the cars overnight. Because at night, there's nobody in the shop. The lights are off. They're not using the air conditioning. They turn everything off, and they make that capacity available for the cars that they're going to sell or that they're servicing, so they can have a full battery in the morning. And the cars rotate automatically. So there's no need for someone to be there to change the car from the fast charger, then every hour change the car and bring another car in. So that's another type of commercial application. So you can use it for fleets or for car dealerships, which are commercial applications, but they are not for the road. So if you want a fast charge and you're on the road, talk to Dave or to Ben at DAD Sales and get a level 3 charger from Flow. That would be a different animal. If you're in a commercial mall and you want something, this is not going to work for it. Is that clear? Okay. All right. Very good. So, are there any more questions so that we can move forward?
Yeah, one more question.
Okay, one more question.
Hi, I have a question from an EV user. So there's no way to predict for the user how much charge I will have in the morning. And
Yes.
the second
No,
question
I'm-
would be what happens, let's say, on a Friday night before a long weekend when everybody's charging for their planned road trips, and everybody needs 100% charge in the morning.
Okay. On the first question, yes, there is an anticipation, and we can provide a written warranty. And that written warranty is based on this. Okay. So this 31%, we can tell you that the car is going to charge only for 3 or 4 hours, depending on the ratio of the installed capacity divided by the actual capacity available. So you see this ratio. So when we have the 24 cars, we said we needed 512 amperes, but we're not having the 512, we're only having 160. And the ratio between those 512s and 160 represents only 31%. So if the window is limited to 12 hours, overnight, they're going to charge only for 3 hours and 43 minutes, and that's our guarantee. So depending on the car that you have, you know how much range you are going to accumulate during that time. So let me pull here our website. And in our website, in the EV charging page, we have a table that lists the EV charge times of most vehicles. So depending on the car that you have, you can look at the rating based on the EPA rating and determine how much charge you're going to get in those 4 hours. We already have a table for the range in kilometers that you're going to accumulate in those 4 hours. On average, you're going to get 134 kilometers in those 4 hours. So that's the expectation, and that has to be managed from the start. So people should know that that charger in that building is being controlled by an energy management system, or that charge port is being controlled by an energy management system that will guarantee 3 hours of charge overnight equivalent, or 4 hours of charge overnight equivalent to 100 kilometers in range. Now, when everybody, number one, when people want to have a road trip, you cannot maximize the energy, because the energy is the energy. It cannot be created or destroyed. It can only be transformed or managed. So if you only have 100 kVA in capacity, you only have 100 kVA. And what we do is we split it equally amongst the cars. So if you live in a building and you're going to have a road trip for the next day, either you don't go to work on that Friday or you work from home, to let your car accumulate charge so that on Saturday morning you got enough to start the road. But even at a full battery, you're going to need to stop somewhere to charge. So you got to take that into consideration. There's multiple strategies, but most EV owners, and I can tell you, I've been an EV driver for the last 6 years, and you just plan a little bit ahead of time, and you're perfectly fine. Most vehicles come with a map and an app that will show you where the fast chargers are located, and where you can charge, and how you can pay. If you have a Tesla, you just map the address where you're going, and it will tell you where you have to stop and for how long, and it is that simple. I hope I answer your question.
Yes, you did. Thank you.
Okay. No more questions. So should I go ahead? I see Joshua Deck there. Yeah. Okay. All right. So you can take a look at our website. We provide software. So when you buy a metering system from Intellimeter, we provide with the metering system a data collection unit, and that data collection unit holds a meter platform, a software platform called iMeter Data. That iMeter Data allows the user, whether it's you as a property manager or as a building operator, to look at reports of the consumption. And these are simple reports. These are basically Excel sheets with the kilowatt hour or the accumulated water consumption over a period of time. We have other more complex software offers like the iMeter Energy Analysis, the iMeter Billing. If you want to do invoicing for that energy or invoicing for that service, they're very flexible, and we can tell you more about the metering. The billing allows you to add fees, to add services. We have a customer, for instance, in Ontario that rents as well the hot water tanks. So he wanted to add the hot water tank rental to the invoice. Okay, fine. So he has a field. He can craft the field, put the name. This is hot water tank rental. And when the invoice is generated every month, it has that. And then you have the ability to add penalty fees. So bounce checks fees, unpaid or disconnection fees, and reconnection fees. Whatever you want to add, it's available. I'll for the sake of making the best use of our time, we're going to skip the videos. You'll have the links for that. On electricity metering, we have any meter that you want. As I said, all our meters are Measurement Canada approved, so you don't have to worry about that part. And they're used for sub-metering. We have the single meter, the double metering. Our meters are multifunction, so they provide not just the kilowatt hours, they provide voltage, current, real power, apparent power, reactive power, real energy, active energy, reactive energy, and apparent energy, and power factor, and frequency, and harmonic distortion. So this one is also used for solar systems for single or dual metering. We have what we call the multi-customer metering system. So it's just one meter with multiple inputs for current transformers. So they can be used for instance, different suites. So the 636 has 16 current inputs. The 636, like the I-45, can be installed inside the panel. So they're ideal for retrofitting because they're rated to be installed inside the panel. So you don't need an enclosure. In any of our meters, you need an enclosure. They come with the enclosure. It's an IMA 1 enclosure, but it saves you space. All of them are fed from the voltage reference. And that's a great advantage because you don't need to provide a separate power supply for the meter or a separate wiring for the meter. The same wires that you're going to use for putting the voltage reference are the ones that are going to use for powering the meter. So they bring a lot of savings to the installer when they do that, when they use our meters for sub-metering. We carry a full line of socket meters, and you can any ANSI form available. Now, there's like 25 different ANSI forms. The most popular are the 4 JAWs that are for 120 single service, which is 100 amps. Then the 240 120, which is also 4 JAW, that's the 2S. That's available for single split phase systems, typically used in single residential dwellings. And then we have the 5S, the network meter for multiple apartment distribution, a 208 120, and the 7 JAW, which is a 3-phase meter. All these meters are good for 600 volts. So you don't have to worry about doing a 600 volt system. They're good for 600 volts. They're all Measurement Canada approved. So you can use them for revenue. And we can supply them with radio, with modem, Cat M1 modem. So if you got like a pump in the middle of the field and you want to bring in the reading, you can put a SIM card and put in the modem and transmit the information of that consumption to a server, and then we can do all that integration on those socket meters. We have a wide range of water metering for hot water, for cold water. If we don't have an SF61, but we have a food grade meter in stainless steel. So if that's your concern, we can do the stainless steel water metering. We have different sizes. So we start in 1/2 inch and we go up to 8 inches in water metering, and we have special sizes available on order, so we can go up to 12 inches. We have a full line of ultrasonic water meters as well, from half an inch to this, in this case, 36 inches. These meters are good for cold and hot water, so it's a single meter. This meter can be installed vertically, upside down, right side up, it doesn't matter. If you want to control the flow, if you're concerned that the tenant is not going to pay, we have a meter with a remote control shut-off valve. So if the tenant doesn't pay, you can literally remotely close the water supply until they pay. So that's also available. And these meters, as I mentioned, are good for cold and hot water. The On the gas, we resell Elster meters. These are temperature compensated diaphragm meters. They come with a pulse output. We have different sizes, from the 250 up to the 100, from line pressures from a quarter of a psi, a quarter of a pound in pressure, to 25 pounds. Different flows, of course, measurement Canada approved, and they can integrate with our metering systems. In heat meters, you can ask Mark. We typically have stock, except when it's a large order and or when it's an odd size. But we have uh, heat meters that speak Modbus or MBus, and they come with pulse output as well. And you can order it with a power supply. Why? Because in these meters, there's no there's no mechanics; it's all electronics. So they come with a battery. So you're concerned about the duration of the battery. Order it with a power supply, and when you integrate it, it goes in the same wire as the communication, and that will extend the life of the battery. And they're ideal for chilled water systems or for heating glycol loops in buildings that can be easily integrated, and they are measurement proof. The benefit that Intelometer brings is that you don't have to worry about, how am I going to do this. We can work with your drawings, with pictures, and we can make sure that all those meters that are installed are integrated into what we call the DCU, the data collection unit. And that data collection unit is the computer. Remember, in the EVCMC, there was a computer. That computer can talk to the building automation system, can be standalone. We can tie it to a server at the property management facility or the property management office, or provide that information to a billing company. It really doesn't matter. You can work with it. All you have to do is tell us what you need in terms of submetering, and we can literally supply the equipment and make it happen. The In those 32 years, we have a lot of experience. We've done large developments, and if you go to Las Vegas and like gambling, go to the old MGM. Now it's called the Area. We have close to 5,000 meters. We were fortunate to submeter airports. Unfortunately, not in Alberta, but we've done BC, Winnipeg, Manitoba, Ontario, and Quebec, and Nova Scotia. We submeter airports. So when you come to Toronto and you land in Pearson Airport or in Billy Bishop in the Island Airport, make sure that when you go take the coffee, that coffee shop is paying their water, their gas, and their electricity through an Intelometer submetering system. We've done hotels, multi-familiar developments, data centers, factories, laboratories. And what we bring is literally the availability to give you that information on how the energy is consuming the building, so that you can understand and then take action, and be able to conserve, and conserve not just the resources, the water or the energy, but also money. So in general, when a submetering system is well utilized, it saves you money. If you need anything, if you're going to take anything from this presentation, just take this, intelometer.com. Anything you need can be accessed through intelometer.com. You can find all the information of our meters, technical drawings, data sheets, manuals, videos on how to install them, videos on what not to do, and as well our contact information. So, or send us an email to quotes@intelometer.com. But fortunately, in Alberta, you have a good team. I see Joshua sitting right there in front, first line, and Dave and Ben Wells. So they're local to you. They're just a phone call away. We work with them day in, day out. They send the quotations, and Luis from our quotation department is right here. He works on making sure that they get the information that they need so that we can provide the best service that you deserve.